Hello, this is my video for the key activity, the final stage, where I did an experiment with a pendulum. My name is Gustavo Betancourt, and this is start. So I'm gonna start with what is a pendulum. So a pendulum is considered as an object that is suspended by a string or rope on a predetermined place. You can see it there in the GIF of the image, basically what it is. And my justification for choosing this topic, it's because it's a basic thing, but it's also pretty interesting how a lot of variables can affect it. And my main question of the project is, how does the length of a pendulum affects its period? Which basically means that depending on the length of the rope, how much time does it take to move? Now, my theoretical framework comes from Galileo Galilei and the isochronism of the pendulum, which basically tells you that the length actually does affect how much the time goes, as you can see here in the big equation. Now, all of the smaller equations down there it's a pretty interesting concept how the first one works, but only when the angle is small, or it doesn't have that much of a wide angle on where you put the pendulum around. And that depends on using the sen of the angle to see if it's wide or not. If it's wide, you need to use one of the ones that are down there. And they're all different. There's not one that is better or worse. They work on different situations differently and more effectively. The variables that I used, well, I'm going to start. Dependent variables are the ones that depend on the independent one. And in this case is oscillations or time. Then is the independent variable, which is the one that affects the dependent variable, and is the length of the rope. Then we have the controlled variables, which are variables that are not supposed to change. And well, they're not supposed to change, so they don't change, which in this case is the base of the pendulum, the recipient of the mass, the weather condition, and the weight of the mass. On the experimental design, I have this, which is an experiment that I found online that I used as a basis to make mine. Now, this one has different lengths and different times, obviously. And you can see the table with the information and also the graphic, which shows like the projection. But in terms of how I planned the experiment, I basically just made the different lengths of the rope, and I used a fixed mass, which was lentejas on a bag, and I just started doing different pendulums with the different lengths and just took the time. Now, on materials and methods, I used a camera to record myself. I used a phone as a timer. I used different lengths of ropes. I used a plastic bag as the recipient of the mass. I used lentejas as the weight of the pendulum. The base that I used was a hanging plant base that was in my backyard. And the weight that I used to measure it was the ones that you normally use to measure lentejas and stuff like that. So the raw data from my experiment, it's this one over here. The measurements look a little bit small in terms of the length, but it's because it's on meters. Because I use centimeters, but I changed to meters to be more precise. And you can see here that at a simple sight, you can see that it was increasing depending on the length. Then here we have the statistical analysis, which basically I put it on a Excel graph. And the first one, it's the one that I made. And the second one, it's comparing the one from the experiment that I used as a basis and the one that I made. As you can see, even though they're not similar, they're not exactly the same, and that is because I didn't use the same lengths as them. You can see that there is a trajectory that looks pretty similar of going up. Now, my conclusion from this experiment is that at simple sight, it looks like the length does affect it. But according to the theories and everything, it's not super precise. On the tables, you can see that it's not 100% constant, and that is because the angle that I used was wider than the one you need to use the equation that was shown before. Some improvements that I could use for this experiment would be to have maybe a sensor that would tell me exactly at what time it would have a timer, and it would stop the moment that it registered the last oscillation that it did. Also, maybe having a way to be mechanized the way that it drops, because even though I literally just dropped it in order to not use force, there could still be problems with that, obviously. And like I said, me using the timer, it's obviously not 100% precise. And that is pretty much it. Here are my references that I use for the experiment in order to have references of past experiments and also of information of the pendulum itself. And that is all. Thank you for your time.